we're diving into one of the simplest but most fascinating scientific experiments ever created. The electroscope may look like just a jar, a rod, and two tiny metal leaves, but don't let its simplicity fool you. This device can detect electric charge, show how charges interact, and even help us understand static electricity.
It doesn't measure how strong the charge is, but it tells us if an object is charged and whether the charge increases or decreases.
The very first electroscopes was invented in 1600 by William Gilbert, an English scientist who discovered that some materials become charged when rubbed. These early electroscopes helped scientists understand static electricity and laid the foundation for many electrical discoveries. These are the parts of electroscope. First, the brass disc. The brass disc is a conductor that collects electric charge from an external source. Function: it serves as a primary contact point for collecting charge.
Brass rod. Brass rod is a metal rod connected to the brass disc at the top and the gold leaf at the bottom. Function: it transfers the electric charge from the brass disc to the gold leaf.
Gold leaf: a very thin piece of gold foil attached to the brass rod inside the electroscope. Function: the gold leaf responds to the charge. If charge reaches it, the leaf moves away because like charges repel.
Glass case. The glass case is a protective covering around the gold leaf and brass rod. Function: it shields the delicate gold leaf and other parts from air movements or disturbances, allowing the electroscope to work accurately. Metal foil. The metal foil is a part located near the bottom of the gold leaf electroscope, often connected to the base or grounded. Function: it can help with charge distribution or act as a grounding point. Insulator plug. The insulator plug is a part that supports the brass rod inside the glass case. Function: it prevents electric charge from leaking out or being conducted away from the brass rod and gold leaf through the base of the electroscope. It helps keep the charge within the system for accurate detection.
How do these parts work together?
When a charged object is brought near or touches the brass disc, the charge quickly travels through the brass rod and down to the gold leaf. If there is enough charge, the leaf rises or separates from the rod because similar charges push away from each other. All the parts support this process. Some guide the charge, some protect the device, and the gold leaf gives us the visible signal. Together, they allow the electroscope to detect electricity in a simple but effective way.
Different charging methods.
The first method is the friction. When two materials are rubbed together, one gets electrons and the other loses electrons. For example, rubbing a balloon on your hair charges the balloon. When you bring the charged balloon close to the brass disc, the leaf instantly responds, showing that friction created a static charge.
The next method is conduction. Here, the charged object actually touches the brass disc. Because they make physical contact, the charge transfers directly into the electroscope. This makes the gold leaf spread apart more visibly since the electroscope now holds the same type of charge as the object.
The last method is induction. In this method, the charged object doesn't touch the electroscope at all. Instead, bringing a charged object near the disc forces the charges inside the electroscope to separate. One side becomes more positive, the other more negative, and this charge separation causes the gold leaf to move. Induction shows that even without contact, electric charges can influence each other.
Overall, the electroscope may be a small instrument, but it plays a big role in understanding electricity.
Through its simple parts and clear movements, it shows how charges behave and how friction, conduction, and induction works. It helps us see something invisible, electric charge, in a way that's easy to observe and understand.